Hi. In this video we're going to talk about adding and subtracting fractions. First we'll do proper and improper fractions, and then second we'll add and subtract using mixed fractions. So first, if the denominators are equal. So if we had two fractions, suppose we had 5 over 8 plus 3 over 8. The denominators are the same. So when the denominators are the same, we just add or subtract the numerators. So this would be 5 plus 3 and put it over the common denominator. So here we've got 8 over 8, which is equal to 1. Okay, we'll just do a couple examples here. 16 over 7, an improper fraction, plus 5 over 7. 16 plus 5 is 21 over 7. 7 goes into 21 3 times, so that would be in its reduced form. Now these two equal whole numbers when we add or subtract, but they don't have to, of course. So if we had, say, 13 over 12 plus 3 over 12, again they have a common denominator, 12, and if we add the numerator, we will have 16 over 12. Now, to reduce to lowest terms, we would look for what number will divide into both of these. So I notice that that would be 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. Now we could convert this to a mixed number. 3 goes into 4 once, with a remainder of 1 over 3. Now if we were subtracting, we do the same thing. Say, for example, 27 over 15 minus 2 over 15. Instead, we subtract. So this will give me 25 over 15, both of which divide by 5. So 5 over 3. 3 goes into 5 once, with a remainder of 2. Okay, and one last example. Say we had 20 over 3 minus 14 over 3. So 20 minus 14 all over 3 is 6 over 3, which reduces to 2. Okay, so now if the denominators are not equal. So if the denominators are not equal, then we first find a common denominator. So we'll call that the LCD, or the least common denominator. So for example, if I have 2 over 5 and I want to add 1/3, I can't add them because the parts are not equal. So fifths are smaller than thirds, and we can't add them together unless we make them out of the same thing. So 5 times 3 is 15. So we're going to make both of these out of 15 by multiplying the top and bottom of the fraction by 3 and this one by 5. And you notice by doing that we'll have 15 in the denominator. 2 times 3 is 6. 5 times 1 is 5 over 15, and then we can add or subtract in the usual way. This doesn't reduce, so we would just stop there. Okay, so we'll do a couple examples. 17 over 2 plus 5 over 3. The common denominator would be 6, so we multiply the first one by 3 over 3 and the second one by 2 over 2. 17 times 3 is 51, and 5 times 2 is 10, and this will be 61 over 6, which is an improper fraction. 6 goes into 61 10 times, that would be 60, and there would be 1 remaining. Okay, we'll do a couple subtraction. Say we get 3 over 7, we wanted to subtract 2 over 9. So our common denominator, 7 times 9 is 63. So we're going to multiply that by 9, and this by 7. So we will have 27 over 63 minus 14 over 63, which is 13 over 63, and that's in reduced form. So we would leave it like that. Okay, this next one, the common denominator, is a little bit trickier to find. So we could multiply 12 times 15, and that would be a common denominator, but it's not the least common denominator. So if you notice both 12 and 15, what they have in common, if we were reducing a fraction with both of them in it, for example, we can divide them both by 3. So they already have a 3 in common. So they have a 3 in common already, and they need a 4, and they need a 5. So 3 times 4 is 12. 12 times 5 is 60. So 60 would be the common denominator. We don't put the 3 in twice. But you don't need to have multiplied this out. The 12 is here. We need to multiply it by 5 to get 60. The 15 is made up of the 3 and the 5, so we need to multiply it by 4 to get to 60. So this will be 15 over 60 minus 4 over 60, which is 11 over 60, and that doesn't reduce. Now we could have, say, a whole number and adding or subtracting a fraction to that. And what we would do is first convert the whole number to be a fraction over 1, and then we proceed in the usual way. So we want a common denominator of 4, so we only need to multiply the first one by 4 now, so they'll be equal. So this will be 8 over 4 minus 3 over 4. They have the same denominator, so 8 minus 3 is 5 over 4. That's an improper fraction. So 4 goes into 5 once, with the remainder of 1/4. Okay, we'll do an adding one similar to this. 5 plus 10 over 3. So you would write 5 over 1 plus 10 over 3. And again, we only need to multiply 1 to get the common denominator, 3. So this will be 15 over 3 plus 10 over 3 is 25 over 3. Now 3 goes into 25 8 times. It's 24, so 8 times, and with 1 left over out of 3. Okay, so that's with improper fractions. And proper fractions, adding and subtracting. So we're going to do the same thing but with mixed numbers. So we can always convert mixed numbers to improper fractions and then add or subtract them in that way. But we can also break them up. So I'm going to show you the method to break them up. So for example, if we had 3 1/2 plus 4 5/7. Okay, so how you can break up your mixed number is to say that this is 3 1/2 and this is 4 plus 5 over 7. Now, when we look at this, we can take the 3 and the 4 and add them together to give 7. And then we can add the fractional parts together. Okay, so now the fractional parts, these two do not have a common denominator, so we need to create a common denominator. So we'll multiply this one by 7 and this one by 2. So we'll have 7 plus 7 over 14 plus 10 over 14, and now we can add these together. 17 over 14. Now, to make this into a mixed number again, to put them back together, we need to write this as a mixed number first. So 14 goes into 17 once, with the remainder of 3. And now 7 plus 1 is 8, and 3/14. So that's how you would do it. Let's recap. You break it up, and then you add the whole parts to get 7 and the fractional parts to get 7 over 14. We reduce this to a mixed number, and then 1 plus 7 is 8 and 3/14. Okay, so we'll do that again. 3 and 2/7 plus 1 and 3/7. So this one's actually easier. Let's break it up. You notice that the fractional parts are actually over the same denominator already. So we have 3 plus 1 is 4, and 2/7 plus 3/7. 2 plus 3 is 5/7. And this is a proper fraction. We don't need to reduce it, so this is just 4 and 5/7. Now if we had, say, for example, a whole number plus a mixed number, we can just add these together, because this is 8 and 1/3, and so there's really nothing to do. 8 and 1/3. And actually, anytime we have a fraction that's a proper fraction, we don't need to make this over 1 and add them together. We can just see that this is 6 and 3/7. So no further work involved. Okay, so now what if we are subtracting mixed numbers? So if I say up here, if we're subtracting, we may have to borrow from the whole part to be able to subtract. So let me show you what I mean. If we have five and 3/7 minus 2 and 1/7. So 5 plus 3 over 7 minus, and we want to subtract the whole 2 plus 1/7. So we actually want to subtract both the 2 and the 1/7. So when we split this up, both the 2 and the 1/7 should be negative. Now we have 5 minus 2, which is 3, and we have 3/7 minus 1/7, which is 2/7. So we have 3 plus 2/7. And I just made the first one work nicely. So the second one, I'll show you what I mean by the borrowing we talked about. So if I had 5 and 3/7 and I want to subtract 2 and 5/7. Similar question. I changed that 1 to a 5. Let's break it up. We want to subtract both the 2 and the 5/7. We talked about that up here. So we have 5 minus 2, which is 3. But now we have 3/7 minus 5/7, which we can't do without getting a negative. So what we end up doing is what we call borrowing. So we're going to take one off of this whole part. Rewriting everything else. Okay, so I broke this up. It's still equal. This is still 3. But now we can write the 1 as 7 over 7. And now if we look at these 3 fractions when we work it out, it still all adds up to the same thing, but we have 7 plus 3 is 10. 10 minus 5 is 5. So this is over 7. We have 7 plus 3 minus 5, which is 5. So 2 and 5/7. And we'll do a couple more of these. Okay, so just a couple more examples. So this is just saying if we want to find the LCD if we need to. So let's first do 6 minus 7 over 12. Just to show the breaking this up. So this would be 5 plus 1 minus 7 over 12. And the 1 can be written as a 12 over 12. So 5 plus 12 minus 7 is 5. So this is 5 and 5/12. Okay, we'll do a second example. Three and 1/2 minus 2 and 5/7. So we'll break this up. 3 plus 1/2. Remember to subtract both the whole and the fractional part. So 3 minus 2 is 1. And we've got a 1/2 minus 5/7. So I believe we're going to need a common denominator here first, and then we may need to borrow from this one. So let's find the common denominator first. We would multiply this by 7 and this by 2. So we'll 7/14 minus 10/14. So the question is, 7 minus 10 is negative, so we don't want that. We can't show a mixed number as negative. So we want to borrow here. So there's nothing really to borrow, it's already 1. So we'll just do a common denominator, or write everything over 14. So now we have 14 plus 7 minus 10, which is 11/14, and that would be the answer. And it makes sense that this number is less than 1. We had 3.5 minus 2 and something that's bigger than 1/2. So we're subtracting the 2 and we're subtracting more than 1/2. So there would be something that's less than 1 left. Okay, so just another example. The last one, 5 1/4 minus 3 1/2. So we'll break this up. Remember to subtract both whole and fractional part. 5 minus 3 is 2. And we need a common denominator for the fraction. So we're going to multiply this. Actually, the common denominator would be 4. We only need to multiply this one by 2. So we'll have 2 plus 1/4 minus 2/4. Now we can subtract them, but it'll give us a negative, so we want to borrow 1. So we'll break this up. 4/4, 1/4, and 2/4. So we have 1 plus 4 plus 1 minus 2, just 1, and that's 5 minus 2 is 3, 3/4. So 1 3/4. Okay, so that's the end of this video. Thank you for watching.